All right, so in this video, we're going to be going over practice test one, exercise two, right? It's an extremely mechanical question, right? There's not really many concepts you have to know, right? It just wants us to simply solve ax is equal to zero, right? Nothing too fancy about it, right? So how are we going to do that? We first want to get this into a better form. We want to get it into an echelon form. Now, if you want to, you can definitely put this into reduced row echelon form, but I find that it takes like more time and I feel like you get less bang for your buck, right? And if I'm on a test, I want to get these questions done fast. So what I like to do is just get it into an echelon form and then just work from that like with that sort of like bottom up approach, right? So let's go ahead and get this solved in this, right? So I have this matrix here already sort of like copied, so we're just going to use that. Right. And again, our goal is to get into an echelon form. So what do we need to do? We need to first find our pivot, right? So look at row one. Where is your pivot? Right. The first non-zero entry I have is -1. So he's going to serve as my pivot, right? That means that I need zeros all below that -1, that pivot, right? So what we have to do is we have to start, eliminating those numbers. So what I'm going to do is I'm going to say, well, where's the first zero that I want? I want to put it in row two. Now, if you want to, you can start off with row three. That's totally fine, but I just like going sequentially. So we're going to start with row two here. So I'm reassigning row two. So what do I have to do in order to change it? If I multiply row one here by two, right, I get -2. So then if I subtract row two from this, right, then I get -2. So that gives me 0. That's exactly what I want. So let's translate that into the text here. So 2 times row 1 is what I said, and then I just have to subtract row 2 here, right? So what is that going to give me? It's going to give me the same row 1 back because I'm only affecting row 2, right? So I got a 2 here. And then of course row 2 is the thing that's going to change, right? So then 2 times this gives you that -2 minus this will give you that 0. If it gives you anything else, then you need to check your row operation and check your calculations, right? Because if you're not getting a 0 here, then something's very wrong, right? Okay, so then 2 times this is 2 minus -1 is going to give you a 3, right? So we'll just place a 3 there. And then of course, 2 times 2 is 4 plus or -1 is going to give you a 3. Right. Okay, so then everything else can stay the same. 1, -2, -3, 0, 1, 1. Okay, so now my goal is to get a 0 right here. How am I going to do that? Well, I can just say row 3, right? So row 3 is assigned to, well, if I just take row 1 and I add it to row 3, right, then I get a 0 there. So we're going to say row 1 plus row 3. Okay, so what does that leave us with? It leaves us with, so these rows are going to be unchanged, so I'm just going to insert them. Okay, so then now I actually have to, do my addition. So this plus this gives you a 0. If it gives you anything else, then something is wrong, right? 1 minus 2 gives you then -1. And then, of course, 2 minus 3 also gives you -1, right? Okay, and then row 4 remains unchanged, right? Okay, so what I can do here is, well, I can get my second pivot, right? Because I've already cleared this column. That's nice. Let's go ahead and work with a different pivot now, right? So let's go to row 2 and identify the pivot. The pivot is right here, the first non-zero entry inside of row 2, right? So I need zeros here. What I can really do though is see that all of these are scalar multiples of each other, right? So if I reduce row 2 down to 1, 1, just by dividing it by 3, right? My row operations are actually going to be like really easy, right? And then what I can also do is see that these two are going to be 0, right? And why did I say that? Because these rows are just scalar multiples of each other. If I reduce this down to 1, 1, and I can divide this by -1, well, what I'm going to have is a 1 here, 1 there, 1 there, 1 there, right? And all I have to do is just like take row 2 and subtract it by like row 3 and assign that to row 3 and like do a similar thing with row 4. So I'll show you what I mean, right? So if I take row 2 and I just say it's equal to row 2 divided by 3, and I also take row 3 here in divided by -1, then what's my resulting matrix? I get -1, 1, 2, and then 0, and then divided by 3, right? Divided by 3. Then over here, divided by -1, and then here it's unchanged, right? So now it should be pretty easy to get some zeros in here, and even in here, right? So what we're going to do is we're first going to we're going to work sequentially, right? So I'm going to knock out row 3 first, and then I'll deal with row 4 in a bit, right? So row 3 is assigned to row 2 minus row 3, right? So then over here we get, what do we get? We get -1, 1, 2. We get 0, 1, 1. And then of course, if I'm subtracting these two together, I'm just going to get zeros here, right? So I get 0, 0, 0, and then 0, 1, 1. And then I can do a very similar thing with row 4, right? So I can say that, row 4 is assigned to row 2 minus row 4, right? So, I take this, I take that, and I subtract them, I get a 0, take that, subtract them, and get a 0, right? So this is going to be really nice. -1, 1, 2, 0, 1, 1, 0, 0, 0, and then subtract them, right? And then you get these zeros. Okay, so now we've entered an echelon form. Now, if you'd like, you can make this a 0, right? Because this is your pivot in this row, right? So if you want to reduce echelon form, you can divide this whole row by -1, right? And then like do some addition there. But we don't really care for it, right? Or at least I don't, right? Because we can work with this, right? So what was our goal? Our goal was to, I guess, find solutions to ax is equal to 0. Right, and it's been implied the whole time here that I've been augmenting this with the 0 vector, right? I just didn't write it because, if you do any row operations to a column with just zeros, it's just going to stay zeros like the whole time. So that's why people don't really bother with augmenting these matrices, like these coefficient matrices with the 0 vector, is because it's just kind of a waste of space, right? At the end of the day, right? So all right, so we're actually trying to solve, ax is equal to 0. How do we do it, right? Well, first, we should just identify, well, do we have a free variable, right? So let's go ahead and look at our columns and see if we have pivots in every column. That'll tell me if I don't have free variables, right? So let's go to column 1. I have a pivot right here. It's my first non-zero entry, right? Okay, let's go to actually let's go to row 2, right? Row 2 has a pivot here, right? But then row 3 doesn't have a pivot, and then row 4 doesn't have a pivot. So what does that mean? That means that row 3 is lacking a pivot, right? So what I can do is I can say that, row 3, or I guess x3 rather, is free, right? Because it lacked a pivot. I looked at the rows, I found them here, but I looked at rows 3 and 4, and I just couldn't find one. I couldn't find a pivot, right? So that kind of left x3 to be free, right? Because I just didn't have a pivot in column 3, right? So then what I can do to account for that is I can say that x3 is equal to t, where t is some real number, right? So with that, I can use that bottom up approach, right? So I can start with this equation because these equations are useless, right? So I can start up with this equation, try to find x2 now because I already know what x3 is, right? I'm going to find x2 and I'm going to use that to find x1, right? So we're going to work from the bottom up. So what that second equation here is giving me, it's giving me x2 plus x3, but what is x3? It's t, right? And it's like every one of these equations is equal to 0 because it's implied that we are augmenting this with the 0 vector, right? So then what is x2? x2 has to be a negative t, right? Okay, so then that's x2. Let's work with our top equation here and see what we get, right? So it looks like I have negative x1 plus x2. What is x2? It's negative t, right? It's a negative t, and then I'm going to be adding to x3. What's x3? It's t. So what is this really? It's plus 2t, right? Is equal to 0. Okay, so then what can I do here? I can combine these two t's to get, well, just t, right? So I get t on this side, and I add this to the other side. What do I get? I get that, x1 is equal to t, right? So this is t, and then I move it to the other side, right? So now I have all my variables. I just need to kind of like set it up in a nicer way, right? So I have, x is equal to, it's going to be it's going to be 1, -1, and 1, right? So, how I got those numbers is, I looked at x1. X1 was going to be t. Well, okay, well, let me go add this, right? So it makes a little sense. Okay, so then it's this vector times t, right? So how did I get these numbers? Right, I looked at x1, like what is the coefficient next to x1? It's 1, right? What is the coefficient next to x2? It's -1, right? What is the coefficient next to x3? It's 1, right? So then I just take this vector and I times it by t, right? So this is my solution, or my solution set rather, because t can be any real number. So you have an infinite amount of solutions, right? And just like that, we've solved the problem, right? Like this is all they wanted. They wanted ax is equal to 0, where you're really trying to find x, right? So what is x? It's equal to this vector right here. It's equal to this like a sort of like infinite set of solutions, right? And then that's the problem. I hope that helped.